So just to make this thing a little bit quicker and easier, so this is the graph that you have.
Please take out. So how do you have any extra? Everything we distributed yesterday.
It doesn't matter. You can just take a plain piece of paper and draw this. And you know, the numbers actually don't matter so much for now. Just want to kind of convey a few conceptual ideas. Okay, so in this graph you have the demand and supply curve with some polluting good, and this lower supply curve is like the private cost of producing the good. The upper supply curve is the social cost of producing the good. And so the question is, you don't have a social planner, right? So we know that we would want to go from oh shoot. Okay, so we know that you want to move the production from here to here. The question is, what policy should be used to do that? Okay, and how do we figure out the cost of that policy, and how do we figure out who is going to bear the burden of that policy? Okay, so to make this thing a little bit easier, so that we all have the same answer, I'm going to draw a few lines here that you can kind of draw as well. And let me just put some letters here, see if this works out. Okay, so draw a graph like this with these letters, and now see if you can answer the questions which are in that sheet, which is basically what happens if you were to use a a pollution tax versus if you were to use a pollution standard versus if you were to use a pollution reduction subsidy, and see if you can kind of rapidly get some answers. So the policies are a pollution tax, which is equal to $3 per unit, or a pollution standard, which is equal to 5 units, or you could have a actually I'm going to change this. So this is not pollution. What we're measuring here is the quantity of let's say gasoline. So this is a gasoline tax and a gasoline standard. Okay, so this is gasoline, and then the third is a gasoline reduction subsidy, which is also equal to 3. So every unit of gasoline consumption that you reduce, you're going to get $3 by the government. And what I want you to do is I want you to find under each of these policies what is the change in the consumer surplus. So I want you to calculate using these letters. Basically, these letters are good enough. What is the change in consumer surplus? What is the change in producer surplus? And what is the change in the government surplus? And what is the environmental benefits? Those four things. Okay, so let's just kind of go through it. So here, let's look at a pollution tax. Okay, so pollution tax would basically be equal to this. That's the amount of the tax, because if you put that tax on gasoline, then it'll make every unit more expensive. It'll shift up the supply curve, and people will use this price and to determine how much they will consume rather than the lower price. And so the consumption is going to fall. Instead of being here, it's going to decrease. And the price has gone up. Okay. So when price goes up, that's going to be the loss in consumer surplus. Okay. The producers are going to be getting paid, based on this, because that's the tax. So after the tax is paid, that's the price they will get. Okay. And so this So this is the this here is this here is, so previously the producer surplus was this, right? Because this was the price they were getting. This is their supply curve. Now the price that they're going to get is going to be this. So this here is the loss in their producer surplus. Okay. This. Okay, so that's the loss in producer surplus. Not sure why it's not staying there. Okay. Then there is a gain in government revenue. So the government revenue is going to be this amount here. Because it's the amount of this tax, because this is just, this distance times the amount of gasoline units that are purchased. So that's the government revenue. Let me see if I can get the... this whole thing is the loss in producer surplus, and then you have the loss in consumer surplus here. So so the net loss is this triangle here. Okay, that's the net loss. The loss to consumers and producers is bigger than the gain to the government. Okay, but it's still good to do the pollution tax because there's also environmental benefits. The benefits to the environment are this. Because for every unit, we know that the damages are the distance between these two lines. This is the amount of units that are reduced. So this is the reduction in environmental benefits, and that is bigger than this black triangle. So the net benefit to the environment will be this little triangle here. That is a net benefit. Yeah, so if I, yeah, right. Yeah, this H. That. Okay, so with the pollution tax, with the gasoline tax, the consumers have lost, the producers have also lost, the government has gained, and the environment has gained. Okay, so um, you get this outcome, but some gain and some lose. The point I'm trying to get to is that if you have an environmental policy like this, there will be some gainers and some losers. Okay, so now let's look at what happens if you had a um, pollution standard instead of the pollution tax. Okay, so now let's say that the government just says, okay, this is the quantity of gasoline that will be sold. There's rationing at the gas station. And because of that, obviously the price has to go up. Okay. So what's going to happen to producer and consumer and government surplus now? What? Yeah, the quantity that will be sold is fixed. Right. So you're still comparing it to having this, the original. Yeah. 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 Yeah, that's right. Yeah, right. So the consumers will still lose because the price has gone up for them. So they'll still be losing this amount here, but the producers are going to gain. So previously the producer surplus was this. Okay. Now they're getting a higher price, so their producer surplus will be actually that. So whether or not they'll gain will depend. I mean, it'll depend on whether this is bigger than, they gain this, but they lose that. So it'll depend on what the net benefit is, but, there's a likelihood they might actually gain. The government gets nothing in the process. Okay. So the consumer surplus is now, with the quantity standard, the consumer surplus will be that. The producer surplus will be all of this, right? And the total social welfare will be this. So there's still a net cost, which would be this area here. You still lost that area compared to when there was no regulation. Okay? But again, because there's been the reduction in consumption, the environment has benefited, and that's the gain to the environment. Okay, so again, that's sort of the net benefit. So both policies will give you the same net benefit, but in one case, the producers will definitely lose and the government will gain. Consumers will lose. In the other case, there's no effect on the government and producers may actually benefit. Okay, so the two policies can give you the same outcome with different distributional effects. And then let's look at 1/3 policy. So now consider the case where the government says that we will give a subsidy for reducing the consumption of gasoline by from the original level. So the original level is here, and for every gallon that is reduced, the government is going to give a subsidy of $3. So where will the consumption occur now? Same as tax. Why?
Because now if you burn more gasoline, you lose that $3.
Right. So basically, the process, the thought process for the consumer would be, if that's the consumer's demand curve, is that if I were to reduce my consumption by a little bit, I'm going to get $3, right? And that the benefit from that is going to be greater than the loss in consumption, right? So if I reduce it by a little bit, my loss is this, but my gain is going to be $3. So as long as the gain that you're going to get is greater than what you're giving up, you will continue to reduce your consumption, because the benefit from consuming the gasoline is less than $3 until you get to this point here. When you reduce your consumption to, from here to here, your marginal benefit goes down by 3. This is your marginal benefit curve. That's what your total benefits from consumption are. So when you go down from here, as you go down, your marginal benefits will keep on decreasing, and finally at this point is when the marginal benefits go down by just 3 units, so that your consumption will stop here. You'll consume the same amount as with the tax. All right. So for consumers, again, because their consumption, the demand is going down, it's equivalent to the price going up. Actually, let me put it. So let me put it that the benefit of reducing the gasoline is going to the gas stations, not to the consumers. Okay, then it makes more sense. So for the gas station, this is the price that they're getting when they're selling 6 units of gasoline. If they reduce it to 5.5, then the market price would go up to this point. But the government is giving them $3. So they would rather get $3 from the government and reduce consumption. And then that'll be the same all the way up to 5. At this point, it'll be all the way until the price that they would get will be just equal to the what the government subsidy would be. Okay, so you end up at the same point as you would with a pollution tax. And when the gas station reduces the amount that they are supplying, the price for consumers will still go up. So they'll still face that price. The producers will, there's no tax or anything after that, so they are going to still get this entire producer surplus, just like with a quantity standard. But in addition to that, they're going to get the $3 subsidy times the reduction that they've done. So that's going to be, this amount here. So under this input reduction subsidy, they are even better off than under the quantity standard, because not only do they have the higher price, but they also get this payment from the government. Okay. Yeah, that's proportional to the quantity that they've cut down, which was just this amount here. Yeah. And so here the government loses because they are paying this subsidy. Okay. And the net benefit will still be the same. But in this case, the government loses, the producers gain, the consumers lose.
So none of the subsidy gets transferred to consumers?
Not in this case, no. It's all going to the producers. Yeah. Because it's not per unit of what they're consuming, it's all being paid to the producers to reduce what's being sold. So that's the reason.
So what is the net benefit here?
So the net benefit, so we can actually calculate that. So this is the consumer surplus. This is the producer surplus. Okay. So the net benefit to consumers and producers is this. Okay. The cost, and this is just a transfer payment from the consumers, from the government to the producers. So this actually does not count. It's just, it goes to the producers, but it's paid by the government. And so the net cost is still So the net social welfare is actually still that. And just like before, this here is the net cost, and then that is the net benefit to the environment, so that's still the net benefit. So the point of this is just to show that how environmental policies generate gainers and losers, and some you can have similar outcomes, and which policy the government may choose will depend upon who they want to benefit and who they want, not who they don't sort of care about. Okay. So let's sort of look at this sort of related issues of how can one incorporate this in cost benefit analysis. Okay, so like we've said so far that cost benefit analysis is just focusing on these aggregate effects, really just cares about what the total net benefit is. That's the rule. If the net benefit is positive, then you undertake that action. It doesn't matter who gained and who lost, because you can always redistribute later on. So even if the producers gain or whatever, you can tax them and redistribute it. But in reality, that's not always the case, because we know that the government, there are political objectives. The government will try to support the people that give them the campaign funds for their campaign, that the ones that are going to come out and vote for them. So in reality, equity does matter, and a lot of policies that might be efficient don't get selected because they're going to harm the wrong people that the government does not want to happen. So you have to be able to look at equity. So then the question is, how should we as economists consider that? And there are a couple different ways that you can do it. So one is, should we could do this as two separate issues. First, we figure out what is efficient, then we examine its equity effects. And we can inform the government if they ask us that, okay, here's the most efficient policy, these are the gainers and losers. If you choose another policy, it may not be very efficient, but it will be maybe more equitable. These are the costs of being equitable. So that's one way that you can use cost-benefit analysis to inform the government or whoever the decision maker, policy maker is, about the equity impacts of that policy. The second thing is that you can change the way you do cost-benefit analysis so that you actually incorporate equity concerns in your cost-benefit analysis. Okay, so we kind of briefly discussed both of those. So this is just, an example from the book, which says that, okay, there are three different proposals for building pipelines. And there are three companies, they've given three different proposals, and here are the costs and benefits of under two different groups under each one of those. So under Company A's proposal, this is the benefits to the company. These are their expected profits. There are costs going to be imposed on the residents, and there's some environmental costs, and they're going to get a little bit of compensation. These are the net costs to the consumers. And then there is government taxes, and they'll get some revenue, and that's given here. Okay, so if you just look at the net impact, that's in the bottom over here, then you can see that the proposal that leads to the highest net benefit will be to give it to Company B. Okay? But under Company B's proposal, the cost to the consumers is actually much higher than under Company C's proposal. But the profits to the company are the lowest, and the benefits to the government are also the lowest. Okay? So this has a very different distributional impact than, let's say, Proposal A, where companies get the maximum, government gets the maximum, but consumers bear the largest cost. So how should we decide between them? And that's where the issue becomes. Should you go with net benefits and assume that later on we can transfer some of, you can tax the company and return some of the benefits here or not? Is the issue. So then there's a question of why should we care about equity? So why is equity important? And there are lots of reasons reasons why you would think equity is important. One is because the value of a dollar is much more to a person who has less than to a high-income person. So we should weight that more than, a dollar's loss to a low-income person should be given more weight than a dollar's gain to a high-income person. So we should incorporate that. The second is that, you don't want to have a lot of inequality. Some people, we don't want to live in a very unequal society. You don't like to see homeless people and beggars and things like that, and you want to, it also leads to more crime and all that. So there's a moral argument for it, as well as a thing of like preserving, being able to preserve society in general. You can't have too much inequality, and you have to take that into account. There's a minimum, like a poverty line. You don't want people to cross that, and so this, you can come up with arguments why equity does matter. The problem is that in cost-benefit analysis, actually, it is heavily weighted in favor of the rich. And the reason is when you're measuring, here are, let's say, two demand curves. This is the demand curve of the low-income person. This is the demand curve of a high-income person. And we just said we're going to, let's say that there's a project that's going to raise the price. And we said we can measure the loss in consumer surplus. We can aggregate it over all the individuals and come up with the total loss in consumer surplus. This is the loss in consumer surplus for the poor person, and A plus B is the loss in consumer surplus for the rich person. Okay, this A plus B is much bigger than A. So this policy will not get passed because the weight of the a large part of the consumer surplus loss is being generated by the rich person. Okay, so the losses to the rich play a much bigger role than the losses to the poor in this. And the same thing with willingness to pay for environmental improvements. If you have an environmental project and you're measuring the benefits using consumer surplus, you might have a case where a project will be passed because the rich are willing to pay a lot for it, even though it might impose costs on the poor. Okay? So let's say you're trying to decide whether to build a park or to build a school, and the rich are willing to pay more for the park, but the benefit of the school to the poor would be from the school, and their consumer surplus is low. The consumer surplus of the rich from the park is high. You have the park being low. Okay? So cost-benefit analysis favors because of this approach. It actually favors the outcomes that happen to the richer rather than the poor. So then the question is, how do we incorporate these distributional impacts in a cost-benefit analysis? And we could do it in three ways. So the first one is you can just, what we did in the first, with that table, we can identify how the costs and benefits are distributed, and we can calculate them, and we can put them out there and let the policymaker decide. The second is you can say, well, you can calculate these implicit distributional weights, and you could say, okay, if we are in fact choosing the school over the park, then how much weight do we need to give to the poor person's utility to make it worthwhile to build the school instead of the park? And then you can say, is that worth it? If every dollar of loss to the poor is equal to twice as much as a gain to the rich, will that be sufficient, or does it have to be 10 times larger? And then you can decide, what trade-off is acceptable. And then the third is you can actually put some distributional weights of your own and say, we are going to, as a society, we hate inequality, and we're going to value it like this. We're going to say it's 5 to 1 or 10 to 1 or some ratio of weights to the rich and the poor. Okay? So here, this is sort of just what we did, and we can use this to kind of look at these distributional effects of these types of policies. So, for example, if you have an environmental regulation that's going to raise the price to consumers, then the cost to consumers will be this area here, which we just looked at, so it's A plus D. And the problem is that it's not just looking at the costs to all consumers, but among consumers, you have high income and low income consumers. And a lot of the cost of these policies actually ends up falling more than proportionately on the low income people. So for example, the problem with having carbon taxes or gasoline taxes and things like that is that they are regressive. The burden of them falls more on the poor because as a percentage, except for people who don't drive cars, but if you ignore that, as a share of income, the amount of money going into gasoline will be higher as a share of income for the poor than for the rich. Okay? And so when you put a tax, more of the burden falls on the poor. And similarly, if you're looking at distribution of costs and benefits from climate change mitigation on rich countries versus poor countries, the burden will fall much more on the poor countries than on the rich countries. So again, there is this issue of among the consumer or among certain groups who bears the cost. And you can use the same approach to calculate those. If you look at the effects on producers, then we know that cost to producers is going to be this loss in producer surplus, which is B plus E. So, and of course, if this is a very flat supply curve, then this will be very small. If it's a very steep supply curve, this will be large. So the shape of these demand and supply curves will determine what the equity effects are. Okay? And within, again, the industry, which industries will gain and which industries will lose. The ones that will lose are the ones that have a lot of fixed assets. So that, when you're reducing your production because of the tax, you might, they might have to scrap a lot of equipment. A lot of labor will lose jobs. They may not be able to find jobs or not. So a lot of resources will get displaced, and if they're industry specific, the greater the cost of those. And then it depends on which inputs are going to be, are being used, capital or labor, and that's where, those people will suffer. Jobs will be lost and so on, or capital will lose its value, the capital owners will lose the returns. And so who is going to benefit and lose will depend upon the makeup of that industry. And then you have the scarcity rent. That's the gap between the cost of production and the price. Okay, that's caused by any policy that's creating this wedge. Anytime you create a wedge between the demand and supply curve, you create a scarcity value here, and the price, there's a gap. And with a pollution tax, we said this goes to the government. With the quantity standard or with the input reduction subsidy, then this is going to the industry. So, and this is a transfer from consumers to the producers. So if the consumers are the low-income, working-class people, then they're losing, and the rich industrialists are gaining. Okay? Depending on, we haven't talked about tradable permits, but tradable permits like pollution taxes, except that you don't have to pay. You can either give the permits free, and then that trading begin, or you can charge people for every permit for pollution, including every unit. They have to have a permit. If you give the permits free, then it becomes sort of like the input reduction subsidy. They get a certain right to pollute, and they get permits based on that, and then if they reduce it, they can sell those permits and get a return for it. So, and they don't have to pay for every unit of pollution. Every unit doesn't need a permit, just how much, the trading is, they get 3 permits basically. So, and then they get returns for selling credits. So if you have these grandfathered permits, then also there are gains to producers. So a lot of times, I think somebody asked this question of, do we see more tax? Why do we not see more taxes? And why do we see more standards? And the reason is because with these standards and permits, producers are more likely to gain, and whereas with a tax, they're more likely to lose. So even though and for consumers, it doesn't matter actually. Both ways, the quantity is going to go down, price will go up, so the effect on them is not so much. But producers will always lobby to have standards rather than taxes. If you're looking at the impact to the environment, then the benefits to the environment is this, trapezoid here, C, D, and E. And again, this is the overall benefit in terms of reducing the damages from climate change. But who benefits from that also differs across countries or across regions within a country. So if we mitigate climate change, the benefits will come to a lot of developing countries that are more susceptible, and coastal areas and all of that. Whereas actually for the developed countries, especially in the northern regions, they might actually be better off with climate change. Alaska and Siberia and all of those might actually benefit from some climate warming rather than lose. So even the environmental benefits are not evenly distributed and they're not the same for everybody. And if you have global warming, then low-income people are more likely to not have access to air conditioning and ability to adapt to changes in temperature. So across income groups, also environmental damage and environmental benefits are different. So that's sort of one way to do this analysis using cost-benefit methods, is to calculate these and be able to. And so there's a lot of research kind of on this topic, which is why even designing a carbon tax is not straightforward. It's a subject of intense political debate because how you return the tax revenues. If you can use the tax revenues, which we haven't talked about here, but even the tax revenues can be redistributed. You can give them back as lump sum, you can give them back as a rebate on electricity consumption or some energy consumption. Should it be fixed? Should it be proportional to income? Should you use the carbon tax to reduce other taxes like labor income taxes or other taxes and benefit consumers that way? So there's a number of ways that you can try to change the distribution of income with these policies, and so that is often a bigger subject of discussion than what should the carbon tax even be. Okay. So the second thing you could do is you can look at what would be the implicit weights that would need to be attached to a policy that is inefficient but equitable. Okay, so let's look at this example. Suppose the benefits to the rich are 200 and the benefits to the poor are negative 100. So the poor are losing and the rich are gaining. Okay? So according to the net benefit criteria, you will select this project because 200 is bigger than 100. But let's say the policymaker decides not to undertake this project because he cares about the benefits to the poor. All right? So what is the implicit weight that you're attaching to the income of the losses to the poor? Well, you're putting a weight of 2:1. Right? Because if you say that every dollar of loss to the poor is worth $2, then this becomes 200, and you would decide, not to undertake this project. So if you put a weight of at least 2:1, then this project is not worth it. So, you could do a very simple calculation here and just calculate what I just did by saying the implicit weight is 2:1 if you decide not to do this project, even though it is efficient. Okay? And then the third thing you can do is you can actually put explicit weights, and you can say that, based on some subjective decision, you can say we're going to have a weight of, not 1:1, which is what we do in standard cost-benefit analysis, but we're going to put a weight of 3:1. So let's say that you have these two groups, and group A, I believe here is, so group A is the low-income group, and group B is the high-income group, and in this particular case, you have the aggregate net benefits you calculate the aggregate net benefits. They are higher for project 1, and 60, 50 plus 10 is 60. For project 2, they are 50. So you select project 1. And in project 1, it's group B, which is the higher income group, gains, and group A is not gaining as much. If you put different weights, you put a higher weight on group A's benefits, so their benefits are 3 times whatever the actual is, so this becomes 30, and here it becomes 60. Now you would add them up, and you would say this is 60 plus 30 is 90, and this is 80. You would select project 2, and under project 2, group 2 is gaining more than they were gaining under project 1. So you care more about the gains to the group A than to group B, and so you decide that that's, you could put a weight and that will do it. So then the question is, how should you come up with these weights? Is there some mechanism to that, or is it going to be completely arbitrary? And so that's another topic of research. And so one approach that's been used or suggested is that you generate a weight by looking at the difference between the average income and the income of each group. Okay, and to the power of a coefficient or the elasticity of how society's utility changes with this is sort of society's aversion to inequality. How averse are you to inequality? Based on that, if you're very averse, then E is infinity. And you would never choose a project in which a poor person loses. If you are completely indifferent to inequality, then E is 0. Okay, so if E is 0, then the weight is 1. So depending on your aversion to inequality, you would choose a weight that's anything between 1 and infinity. Okay? And then if you have a value in between 1 and infinity, then it depends upon, you give a greater weight, the greater the difference between the income of the group relative to the average. If the income of the group is very high compared to the average, they get a weight less than 1. If the income of the group is lower than the average, they get a weight greater than 1. Okay? So you can use that and basically, depending upon the value for E, you can, depending on that, you can calculate the weights. Then you have these two groups, and you can calculate that and show that your unweighted cost-benefit analysis will lead to a very different result than the weighted cost-benefit analysis. Okay? Simple example of that could be like, let's say how, distributing the costs and benefits of climate change mitigation. So let's say we say that the damages from climate change are, here are the damages for the poor countries, these are the damages for the rich countries. How should you aggregate them? And so here is the income of the poor countries, per capita income of poor countries. Here is the per capita income of the rich countries, and you can calculate. You can use this information to calculate the weights that should be attached. So and then you use a value of E, and then multiply this by the weights. So from this, these weights turn out to be just the average divided by the income of the specific country, and to the power of some E, and then use that to calculate what are the aggregate damages and whether these aggregate damages are greater or less than the cost of abatement. Okay? So there's some literature on what the value of E should be, and basically suggests that the value should be between 0.5 and 1.2, and so that's sort of the general idea. You come up with the weight and then do the cost-benefit analysis.
E is based on?
E is it's sort of the aversion to inequality. So if the inequality increases by 1 unit, then how much should your weight it's not a very well defined term that is hard to put and I guess one could go more into it to look at it. I haven't really seen a very good definition. People kind of just end up with I've seen these ratios, but I haven't really seen what is the original source where they get them from. So let's say that you have these choices. You've got several choices here, A, B, C, D, E, and these are the net benefits to group. So here are the net benefits to group 1. Here are the net benefits to group 2, and you're told that group 1 has income of. Oh shoot! I did the wrong. So let's say that you've got. Okay, so group 1 is incomes above 15,000 and group 2 is incomes under 15,000. So group 2 is poor, group 1 is rich. And these are, if you do a simple unweighted cost-benefit analysis, then you end up with, these as your net benefit, just the sum of these two columns. And so the question is, according to this net benefit rule, which projects would you select? Okay. So which ones would you select based on the net benefit rule?
Project B.
Yeah, so you would select, if you could select all projects with the positive net benefit, then you'll end up selecting A, B, and C, right? Now, for which of these projects would, equity be an issue? Sorry, say it again? So the question is that for which of these projects, A, B, and C, would you be worried about equity effects? C. So under C, group 2 is losing, but also under project B, right? B and C, even though the net benefit is higher, but group 2 is actually losing. So based on, for equity reasons, you would not want to select these, right? And what about project D? Right, but so this is a project which you would not select based on the net benefit rule, but you would select based on the equity basis, right? So so really the concern is on these three. This one doesn't make sense for either equity or efficiency, and this one also, at least group 2 is not losing, even though they're not gaining, but it's not such a big. They're not worse off because of this. So it's really for these three projects that you might have to think about. There's a trade-off between equity and efficiency, and then you need weights, so you need some other, decision-making process to figure out which one to go, or if you can see that if the government selects this project, then it must be because they care about the poor. If they select this, that means they don't care about the poor. So it tells you a little bit about the political economy of the process, and that's good to know. Okay, so the question, so basically what typically ends up happening in terms of in our research is that unless you really want to get into the whole equity thing and using weights and all, in most cases you might identify a trade-off between equity and efficiency and leave it at that. Or you might kind of say, okay, what if we want to incorporate equity, then how will it affect efficiency? So, and then you can sort of basically identify policies which are both efficient and equitable, and those that are inefficient, efficient but not equitable, and so on. Okay, so we have some time, right, Sangeeta? Okay. So what I want to just run through is an example of half an hour. Okay, so I just want to kind of go through. So if there are other questions, would you like to discuss stuff now, or would you like me to? I was going to give you an example of a paper that we did where we looked at why does a government choose an inefficient policy. So I thought that might be interesting to see how you can do something like that. Okay, so we did this analysis for Brazil, and actually what we did here applies to many other developing countries, because a lot of them have similar kinds of policies in place. But in the case of Brazil, Brazil is sort of the largest producer of sugar, and it's also the largest producer of ethanol from sugar. And it's sugarcane ethanol has been growing, and there is half of their fuel comes from sugarcane ethanol. So they have these flex fuel cars. You can drive them on either any level of gasoline and ethanol, and so half of the 50% of the fuel is from ethanol, but the production, even though they were the most efficient producer of sugarcane and of producing ethanol in the world, but after 2010 the production started to kind of level off. And so we were in the U.S., thinking like we were producing ethanol from corn, and we were catching up with Brazil because Brazil had been producing it from ethanol, for the last much more than the U.S. And then in like 2010 onwards, Brazil's production started to kind of plateau out, and from becoming an exporter to the U.S., now Brazil became an importer of corn ethanol from the U.S. So we were really wondering what happened, what led to this change in Brazil, and we could not figure out sitting in the U.S. what really was going on. So we actually made a trip to Brazil and we talked to the people and tried to get a better handle on what was going on in Brazil that led to this change. So in doing that, we kind of got a better understanding of what are the fuel policies that they're using, and then tried to understand who gains and who loses. Is there a political economic argument for the kind of policies that Brazil implemented which led to this happening? Okay. So this just shows that this is the amount of these are the flex fuel car sales. As you can see, lots of flex fuel cars. This is the ethanol consumption. It was going up till 2010 or so, and then it started declining. This is gasoline consumption. Up to 2010, it was relatively steady, and this was rising, and they kind of became half and half over here. And after that, gasoline consumption continued to go up, and ethanol consumption fell down, right? So and it was not obviously because of any changes on the demand, because people were still buying flex fuel cars, so they were still able to consume it. So it must be something on the supply side. Okay. So we looked into, well, what are the policies that Brazil follows? And so Brazil actually has a blend mandate. Just like in India, you have like a 5%, 10% mandate to blend ethanol with petrol. They had a 18 to 25%. It varied over time, but it was 18 to 25% has to be pre-blended and sold, and that fuel is called gasohol. But in addition to that, they also sell ethanol. Like 100% ethanol is sold at the gas station. So when you are a car driver and you go with your flex fuel car, you will fill up whichever mix you want. You can take a little bit of the blended fuel, you can take 100% of the ethanol, and you will look at the prices of the two and decide whichever one you think is cheaper, you will do that. And the reason that you have that choice is because the energy content differs. Ethanol has gotten 66% of the energy of gasoline. So 100% ethanol is not as efficient as gasoline, and that's why the market actually prices them also differently. But sometimes the prices are not exactly the same, and so consumers can figure out which one is cheaper given the energy, and then they will take more of that. Okay. The government also puts a very high tax on gasoline, like India. So in India too, it's 100% tax on gasoline. The wholesale price of gasoline is half the price that you pay at the pump. And there in Brazil too, very high tax on gasoline. And there is a tax credit. So the tax on ethanol, or E100, which is 100% ethanol, is less than gasoline. And it's 42%. So here it's 110%, this is 42%, so they try to kind of create an incentive for people to use ethanol. This is a big part of the tax revenue for the government. The other policy is that the government fixes the domestic price of gasoline. And that was very similar to what it was in India as well, where the government for many years it was an administered price that was fixed at the pump by the government. It did not vary with the price of gasoline in the world market. So you can see here, this is the price in the world market, and this is the price fixed by the government. So starting up to 2010, the price in the world market was fluctuating up and down, and some years it was high, some years low. But after here, the price in the world market started to go up. This is in 2008, 9, 10, when the prices really shot up. The government kept the price fixed over here. Okay. If you look at the price of ethanol, actually the cost of producing ethanol is more than the price of gasoline, more than the cost of gasoline. So if you were to just leave it to the free market, consumers are not going to buy the more expensive ethanol. They're going to just buy the cheaper gasoline. So that's why the government had to have a policy in order to make consumers buy ethanol. Okay. So what they did was as I said, they put 110% tax on gasoline, they put a 42% tax on ethanol, and they put that 18% mandate. So as a result of all that, the price of gasoline is this red line. This is the original price, the wholesale price. The consumer price was higher, and that was this red line over here. And this yellow line is the price of ethanol. And that varies depending on like the sugarcane harvest and all of those things. So it's not a constant price, it varies over time. But in general, in this time period here, there were lots of time periods when actually the price of ethanol was lower than the price of gasoline. And same thing over here. And this is the time when lots of people bought flex fuel cars because it was cheaper to drive on ethanol than on gasoline. But after 2010, in general, the price of ethanol became higher than the price of gasoline. And in large part, that was because the price of gasoline was fixed. And it, even with the 110% tax, the price did not go up as much. But the cost of producing ethanol was going up a lot because their productivity was not going up. They weren't investing in improving their sugarcane production and all of that. So their sugarcane production was not very efficient, and the cost went up a lot. And this is where people started to drive on, use more gasoline. So consumption of gasoline shot up, and the consumption of ethanol went down. Okay? So then the question is, why did the government choose these policies? Okay, you would think that they have this wonderful crop and they can grow ethanol and they can reduce their dependence on imported oil. They were an importer for a long period. So why did they not, why did they put these policies? And that involved then looking at, so you could think of various reasons. I mean, you could say, well, they have a blend, so they must be wanting to increase consumption of ethanol and reduce consumption of oil and increase exports. And now, by this time, Brazil had actually discovered a huge reserve of oil. And they have, if Brazil is able to extract all that oil, they could have more oil than the Middle East. There's so much oil that they have discovered. It's called this pre-salt thing, and they figured it out and so on. So, the advantage of getting people off oil would be that you could export more rather than consuming it domestically. There could also be, the government may have fixed the price of wholesale price of oil to benefit their fuel consumers, so that they don't have to have the increase in price that the world market was facing. There is also the incentive for benefiting the sugarcane sector by supporting ethanol. And then there is the desire for tax revenue. So there's multiple motivations here. And the question is, what motivated them to do what they did? Or can we figure out, can we be like the psychoanalyst and figure out why the government did what they did? Okay? So that's what we wanted to do in this research. We want to look at the impact of these policies and the gains and losses to different groups, and what could be the political economic motivations and the trade-offs that were being made among these different objectives. And then compare these to what would be under a socially optimal policy based on our net benefit rule if all we cared about was maximizing social efficiency. Okay? So we had this model, is this partial equilibrium model of these sectors, gasoline, ethanol, and sugar too, because sugar is produced with sugarcane, and you use some of your sugarcane for sugar and some for ethanol, so there is that choice also to be made, how much sugarcane to use for what. We had demand curves and supply curves and all of that, and so you can look at some of the details in the paper, but I just want to kind of get you to what we did and what we found. So we looked at different scenarios. There was no policy, which is a without policy scenario. This was the current set of policies. There's a blend mandate. There is a tax on gasoline. There's a tax credit on ethanol, and then there is a subsidy in the sense that the domestic price of oil is lower than the international price. So this is the mix of policies that was currently there in Brazil. What was the first best policies? If they truly were the social planner who cared about maximizing social benefits for their domestic citizens, they would have put a carbon tax because of their emissions, and they would have put an export tax on sugar. So Brazil is a big exporter of sugar, and they would have benefited by putting that tax. So, and then you could do other combinations of policies. Okay? So we looked at what happens under each of these policies: consumer, producer surplus, and prices, and so on. Okay? So if you look at what was the impact of these policies on consumer surplus, and here we're looking at difference compared to the no policy baseline. So the status quo, and I'm just going to compare the status quo policies and the first best. Under the first best policy, a big impact would have been on the international sugar consumers there, because you put an export tax, the foreign consumers of sugar would have to face a higher price, but very little impact on their domestic market. Okay? So consumers would have been better off with the first best compared to the status quo. The status quo led to an increase in the domestic price of sugar. It led to some increase in the international market. It led to higher prices of ethanol and fuel. Okay? What about production levels? So on the production levels, the first best policy would have led to actually more ethanol, less sugar exports, more ethanol, and less consumption of gasoline. Under the status quo, there was not as much consumption of ethanol, and there was less negative impacts on production. What happened to exports? Well, under the status quo policy, you had, so I'm missing my. All right, I'm going to skip this because I've forgotten which color is for. Actually, it's a different graph. So here, so the status quo policy led to much higher exports compared to the first best. Okay, so you compare that, and it also led to higher government revenue. So that sort of starts to give you an inkling of what the government probably was caring about. They cared about increasing exports, and they cared about their revenue. Okay? And those were higher under the status quo policy than under the first best. If you look at the distribution to consumers and producers and all that, this is under the status quo, the red one, and the green is under the first best. Under the status quo policy, huge negative impact on fuel consumers, huge, bigger negative impact on sugarcane consumers, and also on their oil industry. Those were the ones that had a big negative impact, but who benefited? The sugarcane industry. Okay? And emissions were, there was the slight increase in emissions here. Under the first best, there would have been a slight decrease in emissions. Overall, the social welfare was lower by this amount compared to the first best, where it would have been slightly higher. Okay? So, and the thing is that the oil industry in Brazil is owned by the government. It's not a private industry. So this was their own kind of, they were able to impose these losses because it was the national oil industry. Okay? If you look at what happened to government revenue, this is under the status quo, and this is under the mandate. So, sorry, this is the first best with the sugar export tax and the carbon tax, and that's under the status quo. So we got a much greater revenue by doing what they did, and So the point here is just that you could see from here that what the policies that they implemented were more politically acceptable than the first best. They gave higher benefits for the sugarcane industry, higher tax revenue, higher export revenue. They squeezed out the profitability of the oil producers, and and a lot of the cost was actually borne by the fuel consumers. Okay? So the question is, can this be sustainable? And it turned out actually that it was not sustainable, because the oil industry pretty much revolted because they were unable. There were huge losses they were racking up, very much like nationalized industry in India, and that led to, there was a lot of corruption that led to the government being toppled. And since 2012 or so, there's just been a lot of political unrest and uncertainty because of this trade-off that they're trying to do between what should be the social there's a sort of different parties have different views on what should be the level of social subsidization and growth, and so anyway, so this sort of was consistent with what was happening over there, and ultimately the government removed the the cap on domestic oil prices allowed those to rise a little bit, but it still has not been enough for the ethanol sector to recover. So the whole economy, in fact, is in pretty much a bad shape because of the policies that the government has been following. So I think we'll stop with that because I can see you looking at your watch, and so.
Okay, just one thing.
Yeah. Okay. So we have time, so we can talk. I know some people have to leave early for their class, so that whenever you have to leave, that's fine. But we can continue now.
Madam, during your visit to Brazil, have you witnessed impact of Brazilian sugarcane production on the Amazon forest? Is there any?
Yeah, that was a question that we asked. So the question is, one of the things that's been controversial about sugarcane ethanol has been that as the demand for ethanol has gone up, there's been an expansion of sugarcane production, and people are concerned that because crop production expands, that is going to lead to incentives for deforestation, and Amazon is their rainforest, which is already very threatened. It's shrinking in size. It's obviously a lot of species and a lot of ecosystem value. So it's been basically said that sugarcane ethanol is not environmentally sustainable because it leads to deforestation. So we actually talked a lot, and we wanted to find out if that is the case. And the reality of the situation is that the sort of geography of Brazil is such that the sugarcane is really produced in the central southern part of Brazil, and the Amazon is in the northern part of Brazil. So there's so there's no direct impact. It's not as if they're cutting down the forest to grow the sugarcane, because that sugarcane does not grow in the northern part of Brazil. So it's got to be more of sort of this indirect effect. You take your sugar, you expand sugarcane, and you displace some of the pasture land, and then the pasture land, is the cattle can move up, and then they start cutting down the trees so that they have more grazing land, and that's what happens. But the reality of the story here is that actually, firstly, it's very expensive to cut down trees. It's not like you can just go down and cut them up, and unless there's a market for them, you're not going to just cut the trees. So is there a market for the wood, and also then the fact that after you cut down the trees, you can't immediately start grazing or growing crops over there, because it takes 10 years for the stumps of those trees to disappear before you can convert that into agricultural land. So whoever is cutting down the trees would have to wait there for 10 years, and if this is illegal, deforestation, by the time 10 years happen, the land rights have changed, and so the people who cut may not be the ones who can grow the crops, and so the link is actually just not very clear. And when you actually go there, you realize that what is really motivating a lot of the deforestation is the fact that there are these pig iron foundries which are using the wood as fuel wood in those, and those are located right on the outskirts of the Amazon, and that's the source of demand for that wood. And it's not so much that the sugarcane ethanol is pushing into it and making it economically viable to cut the trees, because the cost of cutting those trees, if there wasn't a market, would never be made up for by the revenue you would get from producing sugarcane or any crop 10 years from now. So the economics just doesn't work out. But this is sort of an example of case where people make models and reach conclusions without actually finding out what's happening in the reality on the ground. And so I mentioned, I think in the seminar and maybe earlier, about how there have been a series of papers that have been published in fairly influential journals which have used the kind of models that I was just describing to you, and more complicated global models that have basically said that when the U.S. produces corn ethanol, or Brazil produces sugarcane ethanol, the price of crops will go up, and that will lead to all this land use change, and there will be deforestation and expansion of production in other countries, and it'll impose all these, emissions will actually be higher, and corn ethanol and sugarcane ethanol are worse than gasoline, and it creates headlines in the New York Times, and everybody has this perception that, my God, this is like really bad, and we need to cut down on biofuels. And when you go on, in reality, and you do a more careful analysis, you realize that it's really not borne out by the facts on the ground. And so that, in general, it's always good to, when you're doing any kind of modeling exercises, to do a little ground truthing to see whether this is credible, does it make sense, and before you take the results of a model and run with it and say that the sky is falling. And so we actually, did something similar. We wanted to look at what would happen if you were to produce ethanol from sugarcane in India. So in India, they have the policy that they wanted to get like a 10% blend by, it was supposed to be by 2017, so we're obviously not there. But they wanted to get a 10% blend from sugarcane, but because of this concern that they did not want to use sugarcane juice directly for ethanol, because it would mean that the price of sugar would go up, and sugar is an important thing in India, and so the government said, we're not going to use sugarcane directly for ethanol, but we will use molasses. So molasses is the byproduct of sugarcane that comes out when you're making the sugar, and they said we can use molasses to produce, and we will get to a 10% blend. So we wanted to do an analysis and say, well, can you actually, firstly achieve a 10% blend with the molasses that are being produced, and what would happen if you did use sugarcane? How much land would be needed, and what would food prices go up? Would sugar prices go up? And what's a better policy? So I actually came to India, and obviously from sitting in the U.S., my sort of hypothesis was that, you can't possibly, in India, land is so scarce, and obviously if you divert land to start producing sugarcane ethanol, prices will go up, and so it's obviously not a good idea for India to start producing ethanol. They should probably just import it or whatever. So I came to India, and I actually came with a master's student who was working with me, and he ended up doing his master's thesis, on that topic. And we talked to different people, and we talked to people at IFPRI and so on, and learned a little bit more about it. And one of the things that we discovered was that so the first thing is that ethanol, molasses is not a waste product in India. Molasses is used to produce alcohol. It's a key ingredient in the production of alcohol, and it's also fed to cattle. So if you start to take molasses away from and put that into ethanol, then your alcohol production would suffer, and to some extent your cattle feed would suffer. So you have to take that into account. It's not so much in India. It may not just be a food versus fuel issue. It's sort of an alcohol versus fuel issue too, because you are going to reduce the alcohol production, and alcohol is subject to a very high import duty. So that means that we kind of restrict imports, and you stop producing domestically, the price of alcohol would shoot up, and your consumer surplus would really go shrinking down. So you start factoring that in, you get a very different calculation. The second is that you don't produce enough molasses so that you can use it. It's not going to get you to a 10% blend, and that's what's been happening. We don't have enough molasses. In some years it's a lot, in some years it's not enough. And then the third thing is that actually, India's consumption of gasoline is very low compared to the rest of the world. It's only like, 20 billion gallons or so. So 10% is 2 billion gallons, which is nothing much. And to produce 2 billion gallons, all you really need is 1 million hectare of sugarcane. If you look at the yields in India and you do all of that analysis, 1 million hectares is not that much. It's easy to get 1 million hectares out, especially if you produce it in the right place. So one of the problems in India is that sugarcane production occurs not in the places where most efficient, but it occurs where it was politically kind of supported. So in Maharashtra, they decided that the government supported sugarcane production, and they gave subsidies and all of that, and they set up sugarcane mills. And once you have sugarcane mills, the farmers can grow, will start growing sugarcane, and they're given these support prices and irrigation, and so you start with, Maharashtra is one of the biggest areas for sugarcane production. But it's actually a very inefficient area for sugarcane production because it takes something like 19 months to grow a sugarcane crop. But in UP and Bihar, you can grow it in like 9-10 months, so it takes longer. It needs more irrigation because Maharashtra, you don't get enough rainfall. And it takes up land for twice as long, and you get one crop. So if you could grow sugarcane in UP and Bihar, and you don't need irrigation, you grow it much faster, then you can actually get a lot more sugarcane with less land being required. And so if you grow things efficiently, you can get both food and fuel. And so that was sort of what we found, that actually it's much better, more efficient if you were to use sugarcane directly to produce it rather than relying upon molasses and doing all of that. So, I guess the main thing is that there's lots of interesting problems to study, and it helps to go and actually first understand what is the problem and then try to develop an economic model to solve it, rather than saying, here's the data, and I'm going to go with that and figure out what the problem is and create that. So that's sort of, think about that as you're thinking about what research to do, and so. All right, so I think I'm going to stop here probably to let some of you eat, and then Monday we'll